Hi Year 12, I'm going to do a quick video on the rates past paper question that you are currently working through this fortnight. This is a question on the most common type of reaction you will come across for this topic, where we react hydrogen peroxide with iodide ions, and we do that in hydrochloric acid, usually in acidic conditions, hence the H+. And hydrogen peroxide is an oxidizing agent, and so it will oxidize iodide ions to iodine. Okay, and then you've got the rate equation written there, and it tells you that a large excess is used of both the hydrogen peroxide and the iodide ions. And question A for 2 marks asks you to explain why a large excess means that the rate at a fixed temp depends only on the conc of H+. Now you've actually had a question very similar to this before. And essentially, if you've got a large excess of one or more of your reagents, they're not going to impact the rate because they're just not going to run out. Or certainly it would take a very long time for them to run out. So the rate isn't dependent on them. That reaction can keep going, and you're not gonna run out of them. Basically, you need to phrase it slightly better than that, but you can check the mark scheme for the wording that they're looking for. Okay, now part B says samples of the reaction mixture are removed at timed intervals and titrated with alkali to determine the concentration of H+. State and explain what must be done to each sample before it is titrated with alkali. Now, when I've marked this question previously, people have kind of seen the titration bit and it's thrown them off, and they've talked about adding indicator or something along those lines, or a white tile was a particularly bad response, something along those lines. Now, I think actually in hindsight, this question is a little easier if you look at, if you go to the slide, whatever number it is, in the lesson 13 and 14 folder of Unit 9. So I'm just going to go to that here now. So I want to focus on these bits down here. How might the reaction be followed? So essentially what we're looking at here, you're adding a load of stuff together and you're trying to find out how quickly they react together. And if you change the concentration, what happens to the time it takes for them to react together? Okay, that's it. And there are a number of ways that you can do that. Now, if you are doing a reaction like this one, where you are producing iodine, and you'll get a coloured solution, particularly if you add starch, because iodine will go blue-black in the presence of starch, then you might choose to use a colorimeter. So it's as if any of the reagents or products are coloured, normally iodine, then you can work out the absorbance, and the absorbance of light, that is, because it's a colorimeter, is proportional to the concentration of iodine. So the darker that solution is, basically, the higher the concentration of iodine. And you can do that over a period of time. And the calibration graph is required to do that, but that will give you an indication of how the concentration of your reactants change, and therefore change in concentration over time is rate. That is what rate is. Okay, I asked you in the instructions for this week, or this fortnight rather, to research what's meant by the term quenching, and the reason was for this question. So it says aliquots, so that's portions, 25cc portions, of a reaction mixture can be sampled at different times without disturbing the reaction. So at different periods of time, perhaps every 5 minutes, every 10 minutes, every minute, depends on the reaction, you remove 25 cc's or whatever portion. It could be that much, it could be much, much less. Those aliquots are quenched to stop the reaction. What that means is basically you do something to it to stop the reaction happening in that small sample. And you might do that by cooling it right down. You might do it by diluting it considerably, or you might choose to neutralize an acid or a base. Okay, once you do that, you stop the reaction from occurring in the little portion or aliquot that you have got. And so when you then titrate that, you can work out the concentration of the reagent that is present whilst the reaction mixture from sort of like the main one, that will continue, and then perhaps a minute later you remove another portion and quench it. Then a minute later you remove another portion and you quench that. And then when you titrate all of those, you work out the concentration, you make a note of the time that you removed each portion, and then you can work out how the concentration changes with time, i.e. the rate. Finally, a gas syringe. You've all used that before. It's required practical 3. It is one of the practicals that you would do. In fact, I think this is the method that we use in lesson 13 and 14. And you measure the volume of gas produced over a period of time. Okay, so for this one, it says before you titrate it, therefore you're going to use the quenching. And then how you're going to do that, well, you're going to dilute, or you're going to cool, or you're going to neutralise. Okay? Right, question C, a graph of the results is shown in figure 1. And there it is. Now, let's pay particular attention here to the axes. We have got time versus concentration. And the question asks, explain how the graph shows that the order with respect to H plus is 0. Now, where people go wrong with this question is they think about the wrong graphs. So again, looking at the slides from this PowerPoint, you have come across these graphs before. If you have in your mind the rate concentration graphs, that's these ones here, okay? This is the shape for 0 order, this is the shape for first order, and this is the shape for second order. But this is not a rate concentration graph, this is a time concentration graph. And they look like this, okay? So you can see here that because the gradient is constant, it means that it's 0 order, okay? And I think from memory, the mark scheme won't accept saying something about the line being straight, because that's just a bit rubbish really, okay? So those are the graphs that we're looking at here. Really important to pay attention to the axes. Okay, question D. Use the graph in figure 1 to calculate the value of K1. So, you're given the rate equation here. Right here, okay, and the second mark for this comes from the unit. So it's only 2 marks, so don't overthink it. So we want, what do we want? K, oh, it's not KI, is it, idiot? K1, that's a big one. Equals, so it would equal, what is it, rate over H plus, but we know that this is 0 order. Therefore, K1 just equals rate. So we then need to work out what the rate is, and we can do that using our graph. So we can say change in Y, which is 0.5, divided by change in X, which is 415, gives you, I think, 0.0012. And then the units, well, they're just going to be the units for rate. So it's going to be 0.0012 moles, decimeters to the -3, seconds to the -1. Okay, and that's because this is 0 order. So if you try and divide it by, I think it gives you the concentration here, by 0.5, then you're going to get, obviously, going to get that wrong. Okay, I'm sure you could probably still pick up marks for correct unit. However, you're probably going to lose those unit marks because you're going to, what if you had that? So you'd end up with just S-1 for your units if you included the concentration of H+. Okay, right. The last question, E, so you need to plot, which I've already done. That is about as easy as it gets. The axis scales are really simple as well. And then you need to, where is it? Draw a line of best fit on the grid in figure 2. So having a look at this, if you take your ruler to it, because when I was plotting it to begin with, it kind of looked like this might be straight and this last one was an outlier, but when I took a ruler to it, that's definitely not the case. There is no way of getting a line of best fit, a straight line of best fit through the vast majority of these points. And typically speaking, in the exam, if they want a straight line of best fit, that will be possible nice and neatly. You might have one, maybe two outliers, but no more than that, and it just isn't possible. So that needs to be a smooth curve of best fit. Sorry, I'm holding a phone in one hand.
Hey.
Molly, upstairs. Smooth curve of best fit. Be bold, be brave, use a pencil, and make sure that it is not in any way a series, a series of little straight lines, okay? Right, then finally, crumbs on here. Finally, it says to calculate the rate of reaction when H plus equals 0.35. Show your working using a suitable construction on the graph, which means that you must draw on the tangent because it tells you to show your working on the graph. So you can't just do a calculation, pick some points and do a calculation. 0.35, so it means that when you take your ruler, you need to make sure, sorry, this is the worst camera work in the world. You need to make sure that at 0.35, which is there, that's where you're going to draw your straight line. Okay, and I can't do both of these things at the same time, but that's where you're going to draw it, and I mean you can see the mark scheme for that, and you all know how to calculate a gradient. Okay, I hope that helps. Please do email if you have any more questions. All the best.